Conformation of alkanes. Conformation of alkanes deals with the isomers of alkanes that form due to slight changes in their structure, especially in their carbon-carbon bonds. The conformations start with ethane and occur in all alkanes higher than ethane. What is conformation of alkanes? In the organic chemistry, uh, it is found that you can rotate a single bond of molecule to change the arrangement of atoms without changing the chemical formula of the compound. So isomers of a compound can be created by different forms of rotations about one single bond. So the different between arrangement of atoms due to such rotations of bond are known as conformations. Conformation of alkanes, as we all know, alkanes have a simple CC single bond in higher alkanes. There is no such bond in methane, but ethane onwards, all alkanes have a CC single bond. So this allows rotation of these single bonds to form a different spatial arrangement of carbon atoms, forming different conformations of such alkanes. Now, ideally, this rotation is limitless and thus an indefinite number of conformations should be able to form. But there is torsional strain to consider, which is resistance to bond rotation. This strain occurs due to the repulsive interactions of the other bond in alkanes, which is the CH bond. So this will limit the number of conformations that can be formed. Alkanes undergo additional reactions. The double bond act as a source of electrons, and hence alkenes react the electron deficient species. Picture inserted the addition of halogen acids HX to alkanes is a general reaction that allows chemists to prepare a variety of halo substitutes. Alkane products, the HCI, HBr, and HI all add to alkanes. Picture inserted. Look carefully at the three reactions just shown. In each case, an enzyme matrically substitute alkane has given a single additional product rather than the mixture that might have been expected. For example, two methyl propane might be react with HCI to give 1 chloro 2 methylpropane in addition to 2 chloro 2 methylpropane, but it didn't. We say that such reaction are regi or specific, when only one of the two possible orientations of addition occurs. After looking at the results of many such reactions, the Russian chemist Vladimir Markovnikov proposed in 1869 what has become known as Markovnikov's rule. This rule states that in the addition of HX to an alkane, the H attaches to the carbon with fewer alkyl substituents, and the X attaches to the carbon with more alkyl substituents. Next is the addition of water. What as HCI and HBr add to the alkynes to yield alkyl halides H2O adds to alkanes to yield alcohols through a process called hydration. Industrially, more than 300,000 tons of ethanol are produced each year in the United States by this method. Picture inserted, hydration takes place on treatment of the alkane with water and a strong acid catalyzed by a mechanism similar to that of HX addition. Thus, protonations of the alkane double bond yields carbocation intermediate with reacts with water as nucleophile to yield protonate alcohol or ROH2 plus. Loss of H plus from this protonate alcohol then gives the neutral alcohol and generates the acid catalyzed. The addition of water to an unsymmetrical alkane follows Markovnikov's rule just as addition of HX, thus giving the morely highly substitutes alcohol as product. Next is reduction of alkanes. Hydrogenetic, we describe the result by saying that the double bond is hydrogenated uh, or reduce. The word reduction in organic chemistry usually refers to the addition of hydrogen or removal of oxygen from molecule. More most alkyl hydrogenations either palladium, uh, metal, or platinum as PtO2 is used as the catalyst. Next is oxidation of alkanes, exoxidation, hydroxylation, and cleavage. Just as the word reduction usually refers to the addition of hydrogen to molecule, the word oxidation usually means the addition of hydrogen. For example, plyalkenes are oxidized to give epoxides on treatment with peroxyacid, RCO3H, such as peroxybenzoic acid, and epoxide, also called an oxirane, is the cyclic ether than with an oxygen atom in a three membrane ring. Epoxides undergo an acid catalyzed ring opening reaction with water hydrolysis to give the corresponding dialcohol or diol, also called glycol. The net result of the two-step alkane epoxidation hydrolysis is thus hydroxylation, the addition of an HO group to each of the two double bond carbons. In fact, more than 3 million tons of ethylene glycol, HOCH2CH2O H, most of it used more for automobile antifreeze are produced each year in the United States by exposition of uh, ethylene, followed by hydrolysis. Addition of radicals to alkanes, polymers. No other group of synthetic chemicals has had a great an impact on your day. Today lives as polymers from carpeting to clothing to foam coffee cups. We are literally surrounded by polymers. A polymer is a large something's very large molecule built up by a repetitive bonding together of many smaller molecules called monomers. Nature makes wide use of biological polymers